My name is Mike Liehr. I'm the CEO of AIM Photonics, at least the one that got recently put together, one of the NNMIs for integrated photonics. I also have the position here at SUNY Poly as Executive Vice President for Technology and Innovation. And that's what you're looking at, one of our clean rooms here that is part of a fairly sizable complex of about 135,000 square feet of clean room. We have had roughly 1 year or more effort now putting this program together. It started pretty much with a relationship between SUNY Poly and MIT. We've been active in the field of integrated photonics for about 5-6 years now. Building parts, building and winning several DARPA programs, also winning commercial customers and entertaining commercial customers in their development for their individual purposes. When the call came, it wasn't really that much of a surprise. Clearly, it was clear to us that there was a whole group of people working to make integrated photonics a request from the DoD for an NNMI. When it successfully came out, we teamed up with who we considered our most serious competitor, UCSB, because we figured between us we're unbeatable. And the University of Arizona joined us, Columbia, RIT, the University of Rochester joined in. So we formed what I believe, very strong academic team. Here at SUNY Poly and at UCSB, we have extensive industrial connections. So we bring our respective companies like Global Foundries, IBM, General Electric, Corning here in the East Coast area, Acacia, and then HP, Intel, and Infinera on the West Coast. Between us, we sort of collected a very large number of very high-profile industrial members that were joining us, and I think the success factors are the kind of academics we had, the kind of industrial members we had, as well as the pledges from 3 governments to fund us at a very substantial level to boost the overall available funding for the Institute. In the simplest term, integrated photonics is the concept of taking photonic elements, lasers, waveguides, modulators, detectors, and applying the techniques that have been developed over decades in the semiconductor industry to miniaturize them and put them on a wafer. The wafer may not be a product wafer, it may be an interposer, so a first level package of sorts. And scaling may not be as it is in semiconductors, because most of the photonic elements don't scale as easily below the wavelength. But in general, the concepts are the same, and applying the techniques and this structure that you find in the semiconductor industry, where you have this layered industry where equipment suppliers, EDA providers, end users, and end customers all work together and rely on each other and drive the cost down mercilessly. That idea can be applied to integrated photonics, or to photonics in general, to make it integrated and therefore more cost effective. Doing that successfully will make the likelihood of it being generally adapted in high volumes much, much higher. From our side, this whole effort in photonics started out with a very close interaction with MIT and us. It's a very symbiotic relationship in that regard, because they do what we would call a fabless company's sort of work. They're designing photonic elements, and we are the foundry equivalent of it, so we're building them. So between us, it's like Qualcomm and the Global Foundries, or Qualcomm and the TSMC. They design, we build, and you work very, very closely together, because these things are not independent of each other. But we've done that over 5 years, so we know each other very well. You have the group in UCSB in particular. Interestingly enough, a lot of these folks are from Bell Labs. Not surprisingly, because when Bell Labs hit on harder times in the 90s, they all migrated to a few universities, and UCSB happens to be one of them. And it's very interesting, because I used to work at T.J. Watson, so we all sort of knew each other a little bit, but it was more competitive then. Now it's all, I'm glad you did it and you made it. But at the end, so UCSB is much more focused on the active components. So they have quite a bit of work on indium phosphide and indium phosphide-based devices, or PICs. But they also have integration schemes of how to put a laser onto a silicon wafer, and how to do that successfully, and have transferred that successfully into industry. So that's the main focus there. Arizona, again, it's another former Bell Labs person. The good thing, by the way, on our executive team is that a lot of them have this industrial background. Tom Koch, who is the dean of optics in Arizona, has had 20 years or so in industry in various positions as vice president in Liehr and in Lucent. So we bring a lot of that experience with us and now applying it to something here. The Rochester area is more known for optics and a large number of SMEs. Certainly we take advantage of that. And then in Columbia we have high-speed testing, and a former faculty from Cornell is now there as well. So I expect there to be a lot more also on the how to design a system and how to build a system, not just the testing component. So that's sort of generally how the skills are distributed. They're all complementary, there's very little overlap, but it's very good to see, and we're working on obviously how to optimize that we work for each other, towards each other as a team. The idea behind the NNMI is to build something that is modeled after the Fraunhofer in Germany. And the Fraunhofers are serving the, in this case, local German economy by providing a path for especially smaller companies that have a demand for, say, very small production runs or research that they couldn't afford because they can't afford the infrastructure. So it's the same concept here. So the NNMIs are meant to help US industry. They're not meant to export this, in particular when it comes from the DoD. As you can imagine, there are export restrictions on what we do, as well as ITAR restrictions. But having said that, the industry, as you know perfectly well, is fairly international. And some of the company names that we have, certainly have branches in all countries, but we're trying to focus primarily on enabling US-based economy, US-based companies to work here and certainly do all the work that actually gets performed on behalf of the industry institute and the funding to remain in the US.